Okay, we're going to complete a compressor test. This would be to see if the compressor valves are holding reasonably well. This is a small compressor with 2 cylinders, so there is a limitation to the test. First thing we have to do is jumper out the low pressure switch because we'd be pulling into a vacuum, so obviously the compressor would shut off if we didn't jumper out the low pressure safety control. Next thing we're going to do is front seat the suction service valve, and before we do that, we'll loosen up the valve packing just a little bit. It's best not to use those valves when the packing's real tight. It tends to wear out the packing. So we'll use our refrigeration wrench. After loosening up the packing just a little bit, the valve will work smoother. We'll front seat the suction service valve so that no suction gas can come back from the evaporator or the suction line. We'll turn it on and we'll see if the compressor can pull into a vacuum. It should pull into a vacuum quickly, and it should pull down at least into, say, 24 inches of vacuum without much of a problem at all. Shouldn't take long to do it. This test, mainly the suction valves. The limitation is there's 2 compressors on here, 2 cylinders on this compressor, so really it'll pull into a vacuum if either one of the 2 suction valves are okay. But still, this does give us an idea if it will pull down. Okay, and this compressor pulled down relatively quick, down to about 20 inches of vacuum. Head pressure is way up at 310 psi-G. If the head pressure wasn't quite so high, we probably would have pulled down even better than that. But that's an acceptable test. We prefer to see something lower. The next thing is we're going to observe to see if the vacuum will hold, how well it holds. If the vacuum would not hold at all, that would be an indication that the discharge valves on this reciprocating compressors are letting discharge gas back in from the discharge side back into the suction side. So there's a very slow rise in the suction pressure. Some of that can be natural refrigerant that's in the crankcase that's boiling off. If this is done with nitrogen, you'd see very little pressure change, or you should see very little pressure change. But typically the unit's got refrigerant in it while you're doing the testing. So there's a slight rise there. Let's see what it'll do if we let it pull down again. And it's down about 24 inches this time. And again, we'll watch to see how fast it rises. If there was any substantial damage to the discharge valve, the pressures would equalize quickly, if not right away. So this valve plate in this reciprocating compressor appears to be in good condition. If the valves were bad on this compressor, if you decided that based on your test you feel that the valves are bad, this is a valve plate that is underneath this cast iron head on this compressor. On the top side are the discharge valves. These are actually the valve backers. They limit the travel of the valve. The reed valve itself is underneath these, and it would be similar to that. This is actually the suction valve that's on the other side. That covers up this port right here. When the piston goes down, that flexes. This reed valve flexes, bends, and lets gas in when the piston's going down and creating a suction. So you get a new valve plate kit from the wholesale house, and you pull this head off, clean up the old gaskets, which tends to be a fair amount of work. Make sure everything is clean in there. Don't get gasket material into the cylinders. Protect everything, clean everything up. Put the new gaskets on, put the new valves in as needed. Bolt the head back on there, perform your leak test, evacuate, and put the unit back in operation. Not that bad of a repair.